Okay, I think we can go ahead and get started. Good evening. Welcome to our first live chat for CS 660 database systems. My name is Dr. John Conklin. I'll be your instructor for this course. Tonight, we're going to talk about some fundamentals of database systems. And then in some of the coming weeks, we'll talk about entity relationship diagrams and actually create some SQL code that you'll build a database from. In Unit 3 and Unit 4, we talk about some database administration tasks, and then in Unit 5, some other things to deal with databases and data warehousing and all that fun stuff. So we'll go ahead and get started. First, I'm going to do some administrative items. Our due dates. Remember, initial discussion posts are always due on Thursdays. Your peer responses are due by Saturdays, and then your individual projects will always be due on Sundays. If you're having any problems with meeting those deadlines, please make sure that you communicate with me early as possible to let me know that you may be late or request an extension. I'm more than happy to do that for you. I want you to download the project template from my website. I added a link, I believe, in the announcement section. The first announcement had a bunch of information in it that you should read, and there's some things for you to take action on, like downloading this template. I have some other sample project files out there for you. The worked examples for all of the units are out there because for some reason they don't work in the classroom. You click on the link to download the worked example, and it gives you an error message. At least it does for me. So I had them all downloaded, so I just placed them on my website in a zip file. There's some SQL demo zip in the zip file, and there's 3 files in there that we'll use in week 3 if you'll download those. And then there's just a bunch of other information on my website under the database systems class folder. There's that template that I want you to use for all of the individual projects. It already has the auto-generated table of contents. So all you need to do is add your text to it and your references to make it a lot easier. And I also provide a sample project file, which is a completed project file from IP1 through 5 to give you an example of what sort of information I'm looking for in each section, and provides a good guide for you to use going forward. Then I request that you either email or message me in Messenger acknowledgement once you have downloaded those files and have the template for your projects, because you will be deducted some points if you don't use the correct template for your individual project. So keep that in mind as you move forward. So first, we'll talk about some examples of database applications. I mean, everybody's probably familiar with databases. You can't go online without using some online application or store like Amazon or Google, and those are all supported by backend databases somehow. Not necessarily a SQL database like we're going to use, but it's still a database, and it's used to store data for them. So these are just some simple examples of backend systems or systems that use databases as their backend system, computerized library systems, and there's a whole host of other ones that I could probably add to update the slide, but that just gives you an example of some that are out there being used. Prior to databases, we used file-based systems where every program defined and managed its own data. So in this example, we have personnel department where they may have some employee files. We have an accounting department that might have some checking account information or savings account, or then a loan department that has mortgage loans or installment loans, any kind of loans. But the thing to note here is that the file-based approach for this banking system, they're all in separate files and separate programs, and the data is not shared across those programs because they're all built in possibly different languages. This one shows an example of what a file-based system process is data, what it may look like, where you have your computer system for, like, say, contracts and sales. They all use a data entry and report routine. There's file handling routines, file definition routines, and then it writes it to some sort of file. Now, these programs may be written in different programming languages, and their output files may be different. So it's almost impossible to share the data. You can't share the data between those two because they're both independent systems. Some limitations of that approach: every program maintained its own set of data. Users of one program may be unaware of potentially useful data held by others. Duplication of data was big with those programs. Some of the same data held by different programs. As you can imagine, if you have a company, you have customers or clients, and that information is probably stored in several different of those applications. There's wasted space, potential different values and or different formats for the same item. Because if one department is working once with some information that may be dissimilar across your organization, if they get notice of an update to that information, they may update it in theirs, but the other systems that have that data may also not get updated. Data dependence is another issue. The file structure is defined in the program code itself. It has incompatible file formats. since the programs are written in different languages, and so you can't easily access each other's files. Has fixed queries, proliferation of application programs. The programs are written to satisfy that particular function, like contracts and sales, like we saw in the previous slide. Any new requirement or major changes to that is going to need them to create a new program. The database approach arose because the definition of data was embedded in application programs rather than being stored separately and independently, and there was no control over access and manipulation of that data. Beyond that, that was imposed by those programs. So the result was the database and simply the database management system, or DBMS, which SQL Server is a DBMS. SQL Server Management Tool is the application that we use to control and access our database itself, but the DBMS is SQL Server, is the database management system that encompasses that program that allows us to access the data in the actual database. A database, in simple terms, is a shared collection of logically related data. The metadata provides some description of the data to help enable program data independence, and then logically related data comprises entities, attributes, and relationships of your organization's information in a very structured manner. The database management system is a software system which enables you to define, create, maintain, and control access to that database. The database application program is a computer program that interacts with the database by issuing an appropriate request or SQL statement to the DBMS. In our instance, that will be SQL Server Management Studio. This is an example of that same system we saw before, where they had the independent programs for sales and contracts. Now, with the database system, they may have data entry and reporting in that sales application program and in the contracts, but inevitably the data all feeds through the database management system into the database itself. So now that data for both of those is stored in one central location. Database approach includes a section for data definition language, which provides you the ability to specify data types, structures, and any data constraints you may have. And also all the specifications are stored within the database itself. Some data manipulation language, or DML, which is the general inquiry facility or query language of the data. So highlighted on this little picture here of SQL commands, we are the ones that we will focus on in this class. The DDL and DML, we won't touch on DCL or TCL, those are more advanced for other classes. But here for the DDL, we will touch on create, alter, maybe drop and truncate. And in the DML, we'll work with the select statement, the inserts, updates, deletes for manipulating the data within our database. The database allows for controlled access, which includes a security system, integrity control, concurrency control, a recovery control, and a user accessibility catalog. So there's many different layers in place before you actually get to the database itself. And one thing in databases it's called a view, which allows every user to have his or own view of the database itself. It's essentially some subset of the database. So in this example, you can see we have table 1 and table 2. And then from that, we created a view where we selected some columns from table 1 and from table 2 and combined those together in the view. But the view itself is the SQL code for the view itself was created by your DBA. Right, so it's handy to have views so that you can help control access to specific data elements. There may be sensitive data, let's say in table 2, that you in your department, you shouldn't have access to see. So the DBA, when he builds that view, he just omits those columns from displaying in your view. So it acts as another layer of security. They provide very reduced complexity. They provide a level of security, as I mentioned. They provide a mechanism to help you customize the appearance of the database, because you pick and choose which fields from what tables are going to appear in your view, as long as all of that data is logically related somehow, right? It presents you a consistent, unchanging picture of the structure of the database, even if the underlying database has changed. So if they make changes to the database tables, if they add fields or they increase the size of fields or add additional columns, it doesn't affect your view. So it's kind of, transparent to the user. Some different advantages of database management systems: control of redundancy, improved data integrity and security. It provides you with some increased productivity, improved maintenance through your data independence, improved backup and recovery services, because most DBMS systems have that utility built into them to help you establish a backup program for your data. Disadvantages, of course, like anything, is the complexity. It can be quite complex depending on the type of data and the size of it. It can grow exponentially very large depending on how much data you're collecting, right? The cost of a database management system, these applications are not cheap and can be quite costly for your organization. You may acquire some additional hardware costs because you have to have some place to store the database, right? Cost of conversion is only if you're converting from one database system or from a flat file system to a database. You may have some costs associated with that. Performance could take a hit depending if the database isn't structured correctly or indexed properly. It can cause some issues in your performance and using the database and accessing data. And then you have a higher impact of a failure because now you have this database which is storing your data. If the database fails, then your systems are down. Prior, we had some multi-user database management system architectures. There's some different architectures that are listed on this slide, as you can see. I touch on three of them. Teleprocessing, two-tier client server architecture, and then the bottom one is the three-tier. And we'll touch on each of those independently on the next few slides. So teleprocessing used to be was the traditional architecture for databases. It had a single mainframe with a number of terminals attached. The trend is, of course, downsizing now with Windows-based and servers and all kinds of stuff. A lot of organizations don't use mainframes, but there's probably are still some organizations that use a mainframe because of the cost involved with converting from their mainframe to a different system. 10 years, 15 years ago, I worked with a company that still had a mainframe system, and they probably plan on keeping it because it was just too costly to upgrade to something else. Now, the file server architecture is connected to several workstations across your network, which you may be familiar with. Database resides on a file server, as we see in the picture here. The database management system and the applications run on every workstation. So all those stations have the programs installed. Disadvantage here, you have significant network traffic accessing your database on the file server. A copy of the database management system on every workstation could be costly. You have to buy separate programs for every single computer. And then concurrency recovery and integrity control can be a lot more complex in this setup. The traditional two-tier client server architecture, where client one, tier one, manages user interface and runs the applications. Tier two was the server that holds the database and the database management system. Some advantages: give you wider access to existing databases that may be on the database server, right? Increased performance, possible reduction in costs, some reduction in communication costs, and then increased consistency with it being more structured. And then we have the three-tier client server, where the client side presented two problems which prevented true scalability. The fat client required considerable resources on your computer to run effectively, and then there was significant client-side administration overhead involved with that structure. By 1995, they proposed these three layers, each potentially running on a different platform. It gave you a thin client, which required less expensive hardware. Application maintenance was then centralized. It was easier to modify or replace one tier without affecting the others. And then separating business logic from database functions made it a lot easier to implement load balancing for those servers. And then this environment maps quite naturally to a web environment. An information system, which a database management system is. There are different types of information systems in organizations. For example, transaction processing systems, decision support, knowledge management, learning management, and of course, database management systems and office information systems. These are very critical to your organization. They typically designed to enable humans to perform tasks which the human brain is not well suited. There are resources that enable collection, management, control, and dissemination of information throughout your organization. And there's a little hyperlink if you want to know more information about that. Thing to note, on my website, I also have all of the PowerPoint slides for all of the live chats. I put copies, PDF versions of those out there for you to download and use as references if you like. So feel free to use that at your will. And there's a bunch of other information on my website too that you might like. The database systems development lifecycle includes these different phases, from database planning to database design, application design, implementation, testing, and then some operational maintenance. As you can see in the little picture here, we have analysis, design, development, and deployment, and each of those has different phases. And you can see that is an iterative process. It goes back and forth and down from top to bottom. Database planning, which we do effectively, is very, we'll talk about this in IP2, where we're going to do an entity relationship diagram for whatever database you're going to build. It is management activities, which allow stages of the database system development cycle to be realized as efficiently and effectively as possible. However, it must be integrated with your overall IS strategy of your organization to be successful. It begins by defining the database planning. The mission statement is the first step. It describes the major aims of your database. Those driving the database project within your organization will normally define the mission statement. The mission statement for the database defines major aims, and it clearly clarifies the purpose of the database project and provides you a clear path towards efficient and effective creation of a required database system. With mission objectives, once you have the mission statement, you can define your mission objectives. Each objective should identify a particular task that the database must support, and it may be accompanied by some additional information that specifies your work that is going to be done, what resources you're going to use to accomplish that, and how you're going to actually pay for all that. It should also include a development of standards, which help you govern how your data is going to be collected, how the format should be specified, what's the necessary documentation needed. The SIS planning phase creates a foundation for the final database. It's similar to developing architectural plans for constructing a building and helping ensure that your database project goes smoothly. If you don't have a solid foundation to begin with, when you get further into the project and you're trying to actually develop the database and load it with data, you may have some problems if it's not structured correctly. Systems definition simply defines the scope and boundaries of your database system and the major user views. The user views help define what's required of your system from a perspective of either a particular job role like manager or supervisor, or from an enterprise application area such as marketing, personnel, or stock control. This application may have one or more user views. Identifying those views helps you ensure that no major user of your database has been forgotten when developing requirements for your new system. These views help in development of complex database systems, allowing requirements to be broken down to very manageable pieces. This is a representation of a database system with multiple user views. You can see there are 6 views in this diagram. User views 1, 2, 3, and 5, and 6 have some overlapping requirements. They may have some of the same data elements being returned in the view, which is highly possible. And then 4 is a view where there is no overlapping and very distinct requirements for that specific view. Database design is simply the process of creating a design for your database, which will help to support your mission statement and your mission objectives for the required system. Main approaches are top down, bottom up, inside out, and mixed. This little diagram kind of shows what the top down approach is, some conceptual, and then bottom up is normalization of the data from attributes entity up to the conceptual model. Main purpose of data modeling is to assist in understanding the meaning or semantics of your data. You have to understand what data you're collecting in order to build the database to be effective, right? It helps also facilitate communication about the information requirements that you get. The data model ensures you understand every user's perspective of the data, the nature of the data itself, and the use of data across those user views that you're going to possibly build. 3 phases of the database design as shown in this picture. So conceptual database design begins the process, then you define your logical database design, and eventually you end up with your physical database design where you're actually going to physically build the database from. In conceptual database design, the process of constructing the model of the data is used in your enterprise. It's independent of all physical considerations, so it doesn't matter what database system you're going to use. This design is built mainly on the information in your user requirement specification. It is also the source of information for your logical design phase. So once you have your conceptual design, you then take that and build your logical database design by constructing the model of the data used in your enterprise based on a specific data model. In our example, would be a relational database, but independent of any database management system. So it could be an Oracle relational database, a DB2 database, a SQL Server database. Regardless, it's a relational database, and that's what this design is built on. So your conceptual model is redefined and mapped into this logical data model, like you see an example here. And then finally, you're going to take that logical model, you're going to take it into the physical design phase, where you produce a description of the database implementation on secondary storage, It describes the base relations, your organizations of files, indexes used to achieve this, but it's also tailored to a specific database management system. So in our instance, we're tailoring ours to SQL Server Management Studio Express Edition, which you download for free. You may have to, but probably not have to be involved in the selection of an appropriate database system to support your system. But let's say in our instance where we have our little retail store that we're going to work with in this class, right? Maybe they don't have a current database, or they do and it's very basic, and maybe you want to switch to Microsoft SQL Server. You may be required to participate in the selection of an appropriate system. The main steps are defining the terms of reference of your study, shortlist 2 or 3 different products that you can compare equally, right, using the same measures, evaluate those products using those measures, then recommend a selection and produce a report that you would provide to your manager. So that's the live chat portion. We'll talk briefly about the individual project. At the end of every live chat, I like to go through the individual project and let you know what's expected. And if you have any questions about that project, you can ask those at this time. But for our individual project here, we have a retail store that's experienced significant growth. The customers express an interest in being able to purchase the retail store's products electronically. Currently, the store has a simple website, but it's not clear if the system can support dynamic interaction or website or any online purchases. However, the main database system that's used at the physical store has not been working correctly, however, and that is an issue. And that's the one we're going to focus on for this class, our database in the main little retail store. So they want to eventually integrate it with an online database system with the current order entry system, which is used to support their sales made in the local store. But the local database is not defined properly. It's not working correctly, so we need to replace it. So what can we do to support the goals and objectives of meeting their needs of the customer? So it's assumed we're going to use Microsoft SQL Server Express Edition with Management Studio tools, was chosen as a database platform. There was a link in the announcements to show you how to install it. I think I posted that one already to help you install it, and there's a link to the file. If you can't get the file from Microsoft website, I also have the SQL file for the program on my website that you can download it from there. It'll only work on Windows-based machines. It will not work on a Mac computer and will not work on a Chromebook. So if you have either one of those, you'll have to use one of the alternative methods that I posted. I'll post in whatever unit it is. I think it's unit 3. There's some online sites you can use to check your syntax, your code, or actually just a normal text editor. Any text program you use to type notes in will work as well to make changes to those 3 files that I posted on my website. Using Microsoft Word, the template that I provided, you already have the title page. You just need to update the title page with the course number and name, the project name, your name, and the date. And then the auto-generated table of contents already exists in that template. So I'll know if you use that because it has that template. I added headings in every single section to help you make sure that you address all of the areas required for those sections. So they all have, they have headings for every single point that you need to hit in every individual project. I try to make it easy for you. So just pick that template up and start typing in it. So week 1, we're doing a database systems overview. And then every week, we're just going to add to the same paper. So week 1, you'll turn your paper in. Week 2, you'll just add to the paper from week 1, and so on and so forth. Update your table of contents and then submit it. So every week, you'll add the new section. It has all 5 sections in the paper now, right, with blank headings in it. So you can just leave those in there. Every week, it builds on the next. As noted, when you're done, you'll have a complete database systems development implementation plan when you finish week 5. I provide you with the Word template with headings as well as completed sample project files so you can see what type of information should be completed every week. So make sure you take advantage of that and use it. Some people have found it very helpful. In case you're like, well, what do I put in this area? Just review that sample paper and it'll give you a really good idea because that paper was done very well. So for week 1, we need to address these 5 items. The general business environment for the case study organization. So they want you to pick a small or medium-sized retail store. It can either be a real store that you would like to use, or you can make up a fictitious one. I don't know if you've made up a fictitious one for some of your prior classes. If you have, you can use the same one, that's fine. If you've had this class before and you're taking it again, I can give you permission to reuse whatever you've done before. You just have to put the statement on the front of the paper that it says in the policy for resubmissions. Just email me or message me and ask for permission, and I'm more than happy to grant that for you, because there's no sense in you redoing the work if you've already done it. I want you to be able to take advantage of that. And then you have to include a database systems goal and objective statement. Do a Google search for database systems goals and objectives. You'll find thousands of examples of what those should be, so that should help you. Include a narrative, discusses how this proposed database system addresses presenting business problem. The business problems are going to be whatever you dictate the business problems are going to be for your particular store, right? Include a narrative that demonstrates how this system aligns with the mission statement and strategic goals of the organization, where you also have to identify the mission and goals of the case study store and provide your analysis as to how this part of the project fulfills the mission and our goals. If you address every single area in here, you'll get a very good grade in your paper. Just make sure you don't forget to address everything. The one area that people seem to forget a lot is this last one, where they do this analysis. This analysis part is in every single paper. So make sure you prepare for that and that you include that in every paper that you submit. So that's why it's good to use the template that I provided, because it has those headings. It has the headings, all of these headings for all of these sections in there, to make sure that you don't miss addressing any area. Of course, all your sources should be cited in text and a reference using APA 7. The library has a wealth of information about APA, and librarians are very helpful in answering questions on APA format if you have any, or there's tons of websites out there for APA formatting if you're needing help or have questions about APA. Do some research and look it up, but make sure that you're using the correct format, specifically for your in-text citations and for your references. And if you list the reference in your paper, it should be cited in text somewhere. You don't list a reference if you're not going to cite it in text. So make sure that if you have it listed, make sure it's cited in text. And then naming your document properly with just your name, CS660, and then the IP number at the end. That's helpful because I teach more than one class. So if I download the papers, I know exactly whose it is and what class it belongs to. And then, of course, submit it for grading. My email address is here, and it's in the classroom as well. I have office hours Thursdays and Saturdays, but actually I'm available anytime outside of those times as well. And Wednesdays are our live chats. It just says 7 p.m., but that's during daylight savings. It's 6 p.m. for this class, this term, 6 to 7. I have my website where you can get all of that information from. There's also on the main page of my website, at the root page of my website, there's a section where you can go and schedule an appointment with me if you need to meet one-on-one for 15, 30, or 60 minutes. Just click on that. It'll bring up a calendar. You pick a date and it'll show you the times that are available, and just feel free to set that up. So I have defined office hours. I have to have them. I do it Thursdays and Saturdays, but I have times available on Tuesday, Wednesdays, Thursdays, Fridays, and Saturdays to meet with you. So outside of those office hours that are noted on there. So anytime, I'm more than happy to meet if you need help with anything. Message me or email me. I'm fairly quick to respond if possible. For some reason, since the update in the classroom, the messenger notifications, I don't get those on my cell phone anymore. For some reason, they don't pop up and tell me that there's a message. So, but I do log into the classroom every morning. So I log in. If I see a message, I will respond immediately to you. If you send me an email, those I do get on my phone, I can respond a lot quicker. But I check my emails and my messenger messages quite a bit throughout the day as well. And of course, you can always text me on my cell phone, my phone number is in the classroom. It's usually at the bottom of all the announcements. You can send me a text there if you need to, or call me, whichever way is easier for you to get a hold of me when you need assistance. Make sure you communicate with me if you're having issues getting anything submitted on time. I'm more than willing to work with you, but you have to be able to communicate. If you don't let me know that you're going to be late for an assignment and you just missed a deadline, I'm gonna have to take the 10% off for being late for your assignments. But if you notify me ahead of time, I'm more than willing to work with you and not take the 10% off. I want to make sure that you do as well as you can. So thank you for listening. If you have any questions about anything, feel free to unmute yourself and ask. If not, I hope you have a wonderful evening, and we'll chat again next week.
Hi, Dr. Conklin. This is David.
Hi, David.
I do have a question for you, sir. I know that at the beginning of the class, you wanted us to let you know when we downloaded certain things from the notifications.
Yeah, for my website.
Yeah, where's the best place for us to, or where would you recommend? Would you recommend an email or just an IM?
Either one is fine. I just want to know that you have it so that I know you have the template that you're supposed to be using. So you
Most
can, if
definitely.
you want to send me an email, that's fine. That way I'll have it on record. But I do, once you notify me, I do mark it off in my spreadsheet for the roster that you notified me, you downloaded everything. I just want to make sure that you get that information because it will be very helpful for you.
Okay, most definitely. I had another question, but it slipped my mind. That's fine. If I have anything, I'll get back with you.
Okay, perfect. Yeah, just shoot me an IM or an email and I'm more than happy to help you out, David.
Thank you, sir. Look forward to it.
All right, thank you. Have a good evening.
You too. Bye bye.